record this class. So today's a review class. Hopefully you have some questions we can discuss. Or otherwise, I could just go. Let me open my open math. Oops, I did something wrong. Too many passwords. Okay, so this time is right. Anyone has any questions?
Miss, do you accept late homework?
Okay, you won't see that. I have to switch the screen. Okay, as I mentioned before, sorry, let me close this one. All right, you can see this. So the midterm will cover integration, right? So calculating areas. I'm not going to give you any Riemann sum questions, which is approximating areas. You know, we don't need to approximating areas anymore because since we know integral, we can find exact area. So the definite integral, fundamental theorem of calculus, the two parts, right? So definite integral, fundamental theorem of calculus with two parts, integration formulas, substitution methods, involving exponential and logarithmic functions. With the inverse trigonometric functions. If anything needs, yeah, I wouldn't put it to, you know, so some formulas, right? If I cannot memorize myself, I'm not requesting my students to memorize. If I do have these kind of questions up here in exams, I will offer you the formula. All right, so don't worry about too much about memorizing formula, but at least you should know sine and arcsine, arccosine, all right, the basics, or tangent, maybe the arctangent, the basics, arcsine and arctangent. The second chapter, areas between curves, volumes by slicing. You know what, 2.2, we're not approximating volumes anymore. You know, we can find exact. So we have, yeah, we have a piece of region. We can revolve over x-axis, over y-axis. We get a 3D objects. We have disk methods. We have shell methods. Okay, so we should be able to know those two methods. The arc length of a curve and the surface area of a 3D object. Exponential functions and logarithmic. I don't really remember what was this. Yeah, don't worry about this, right? 2.9, 2.8, 2.6, and 2.5. because we're doing pure mathematics. We're not doing applied mathematics. So basically 2.1. So whichever I assigned you homework, okay. So your homework sets basically your review questions. Chapter 3, techniques of integration by parts. Integration by parts, you should master this, okay, integration by parts, because it's a very basic skill, and it's widely used. Yeah, trigonometry, integrals, substitutions, partial fractions. Then we skip 3.5 and 3.6, so 3.7, improper integrals. So how do we deal with improper integrals? Let's say lower limit, upper limit, not in the domain of the integrand, or upper limit, lower limit involves infinity signs. So that's chapter 3. Chapter 4, totally not in our syllabus, so don't worry about it. Chapter 5, okay, chapter 5, I won't put chapter 5 in midterm, all right? So midterm, I'm going to put in, so final, so we only have 2 exams, midterm and final. So final are the first, so 4, 3, not 4, no 4. So first 3 chapters, so chapter 1, chapter 2, chapter 3. And final will be 5, 6, 7. Okay, 5, 6, 7. But the final, I may put a couple of questions, something I think is really important. You really should have to, you really should have mastered by the end of the semester from chapter 1, chapter 2, chapter 3. Okay, it won't be as many questions, because the final probably will lean on 5, 6, 7, chapter 5 or 6 or 7, but I will still put a couple questions, important questions on final. All right, so now let's see your comments. Will we have questions from last lecture on the midterm? Okay, I answered that. Okay, chapter 5 not in the midterm. You're picking random questions from the homework for the midterm? Probably I will change the numbers or something like that. Yes. So the question type will be exactly coming from your homework, but it may not be, sometimes it may not be exactly the same question. I may change some numbers. But the question types, you're right, are exactly same as your homework. Yes, try J, I do accept the late homework. You won't get full credits, but you will get most of the credits. It depends on how late. Okay, the homework credits will be deducted by how late the homework is. Can you change the due date for homework 10? Homework 10, what's the due date for homework 10? Let me check. Okay, I will change that. Let me see. I will change that right now. I will postpone for 1 week because we have this midterm. Let me see. Okay, available after due dates. Okay, I'm going to change to be 24, okay? 24. Okay, it's been changed. It has changed. Okay, Woodley is asking, do we have to solve the problem the same way the book does, or as long as we get solution is fine? Okay, unless I ask you to use a disk method, unless the question asks you to use a specific method, you can do any way you want, all right? But anyway, it has to make sense, right? But if the question asks you for specific method, you have to use that method. Okay, great, great. Right, I love watching YouTube as well. And anything I want to learn, I go to YouTube. Yes, yeah, from YouTube, you may get a better understanding. You may have a better ways of solving it. Go ahead. If the question does not ask you to go a specific way, yes, please. And then you may inspire me, help me to be a better teacher too, that way. Go over 200 from, okay, let me write down those numbers. Let me write down the numbers. Question 200 from 3.4. Oh, okay. 4 variable partial equation, okay. 3.7, 355. How many questions for the midterm exam? Probably around 20 questions, because we have almost 2 hours. Are we just submitting answers on Blackboard? All right, so now let's talk about the final. The final, I would love to see your lovely faces. So what I'm going to do is, I'm going to use not, what do you call it? Not the Blackboard Ultra. I'm going to send you, how I'm going to send you? I'm going to post a Zoom link on Blackboard. So I read all the detailed information on Blackboard. So I will open Blackboard. I will open Ultra the same time, but I'm going to use Zoom at the same time to see your lovely faces. All right. And so during the exam, you have to show me. You have to have your camera on the whole time until you finish. Because I want the exam to be fair. Okay. I think probably you hate too, if people cheating on you, that's not a good idea, right? And you don't like the feelings. I don't like my students cheat on me either. I teach in Hunter, almost, sometimes I cannot say almost, sometimes, I catch students just cheating in my face, because at Hunter we do, in campus. So everything is, so I choose to teach on campus because I live nearby. I choose to teach the courses on campus. And the feeling, it's really disgusting. The feeling is really disgusting. Someone, is cheating you right in front of you. I don't know how you feel about it when people cheat on you. I just feel awful. So I'm hoping everyone is being honest. All right. So the whole time, have your camera on, and the final will be on campus. So don't allow yourself to do that, right? Don't get tempted to think other people do better than you, or because it's learning. It's about to learn. And if you don't feel like you're going to pass this course this time, so what? You're young, you're energetic, you have a lot of time ahead of you. If I don't make sense to you, register this course in the in another semester, in the fall semester. Maybe you learn better from another professor, so on and so forth. Just try not to cheat, please. Okay. It does no good for nobody. All right, so I'm gonna open two. I'm gonna have 2 links. So I'm gonna open this one, and I'm also going to use Zoom to practice. All right, I'm gonna use Zoom to practice the exam, and And yeah, let me see your questions or comments. I write that down. Yeah, about 20 questions. Yeah, the final was in person. Ali, you're exactly right. It's in person on campus. I live in Manhattan, so I have to go to Brooklyn. Yes, the final is in person on campus. Yeah, so this midterm is going to use Zoom to practice you, and also I'm going to open this link on Blackboard also. Oh, what if you don't have a webcam? You better get a webcam now. You need to get one, or you need to borrow one from someone. Okay. Sorry for that. Sorry, Ali. You know, I think one of the things COVID-19 teaches us is to be ready for this, right? To be ready for education online, to be ready for meetings online. You know, it saves us a lot of times. Ali, is that okay? Get one or borrow one? Okay, thank you. Right, get one or borrow one. You know, I meet my friends a lot of times online. Before we would meet, it would take everybody, you know, a lot of hectic to meet together. Now it's so easy, right? Within one click. You know, me and my friends meet online all the time. Fujun, is the final in person? Yes, final is in person, on campus, on Brooklyn College campus. Oh no, camera for midterm for this coming Thursday. For this coming Thursday, I'm going to read out the details and post on Blackboard. So on this coming Thursday, you need to show me your beautiful face, your handsome face. And the exam will be practiced through Zoom. As you know, I'll post a Zoom link. Rob, what do you mean, or phone? Yeah, your phone has a camera, right? You could use your phone. As long as your phone can show me, okay? You cannot only show me your nose, your eyes, no. You have to show me, because it's supposed to be close booked, right? You have to show me probably like a 3x3, or maybe at least 1x1, I would say. You know, you need to show me it's you, you know, who's taking the exam. Where do we submit our answers for the midterm? Email me, all right, email me. It's just like when you submit your homework, submit to me through email. I will write out those details. Are we allowed a single reference page for the midterm and the final? Yes. You can have a couple of clean papers, right? Can you use a phone camera? You can try. You can try. So I will get online early next Thursday. Not next Thursday, this coming Thursday. So if you have a camera, you know, usually, well, if you don't use camera normally, because I use it all the time, I know exactly how to position myself, you know, like this, right? You can see me like this, but maybe you show me the little table. It is you are doing the work. That's all I have to say. It begins, right, it begins, so our class times is 6:05 to 7:45. And if some students need, we can go until 8. We can go until 8. And I will be online early for coming Thursday. By reference page, I mean one with formulas. I will offer you formulas if you need one, all right? No, I say no reference page, Paul, sorry. Would I be allowed? Okay. Rajab is asking, would I be allowed to use my iPad to write out my work, or should it be written on paper? Paper. No iPad. Yeah, you can use your computer or your phone, because I will post the exam online. So you have to use your phone or your computer. So you have to use it for the exam itself. But when you answer it, you cannot use iPad. You cannot use your computer. You have to write on clean paper. Okay, so everyone needs some clean paper to write on. You have to write on the clean paper. Then take picture, then send to me. Sorry. I know nowadays, you know, we have tendency to type everything on computer. I do too, you know. Yeah, everything I write, I think, you know, I put on my computer. Are we viewing the midterm questions on my open math? What do you mean? The midterm questions, oh, okay, I see. So you mean the exam itself, right? I will post on my open math, and let me see. I probably will post on Blackboard. That's a good question. I haven't thought about it yet. Yeah, or maybe, you know, best to post on both places. I'll try to post on both. All right, just as homework. All right. Okay. Any other questions? If not, we go over those two questions. Actually, you know, we have so many smart people in this class. Let me post those two questions. Let me pull out those two questions. So that's in 3.4 and 3.7. Let's talk at 3.4, 200. So maybe some of you can help us with this. 200. Let me see if you see this. Oh yes, you see this. So 200. So anyone has done this, or should I give everyone like 5 minutes to do this?
Which number?
So this we have 4 variables, and then maybe someone can show us. Because usually, you know, my ideal class is a participation. A lot of times I like students to present, and because this is my first semester teaching this course in Brooklyn, so I don't really know, because I want to have a feel about it. Which number? 200. So 200. So let me put in here. So everyone, and we try question 200. Right, you see we have 4 factors. That means we have to use 4 variables, A, B, C, D. Partial fractions with 4 coefficients. Okay, you could think that way, or better to think you need 4 variables. Yeah. Then, yeah, okay, great. Let me take attendance. Okay. Wow, that's fast. Okay, so 1/6 ln x half ln x minus 1 minus half ln minus half ln x plus 1 ln x minus 1 x minus 2. Oh, you mean x minus 2, I guess. You have x minus 1, you have x minus 3, you have that's n ln x minus 2. I see. Okay. Or negative, okay, let's see. Negative 1/6, negative 1/6 plus 2, x minus 2 divided by 2. All right, okay. Any one of you like to go to whiteboard to explain to us? Especially explain to Paul. Did Paul ask this question? Let me see. Ali, would you like to explain this question on the whiteboard? Oh, I see. Yeah, you could do that. So can you write on it? I can make you presenter so you can write on the whiteboard. And you don't have to show your face. Let me see. Let me make you presenter. I do this all the time with my other classes, but haven't tried it with you guys yet. So now I've made Ali presenter. So that means you can go to the whiteboard. You see the arrow on the bottom? On the arrow on the bottom, you click on it, it shows you share blank whiteboard. Yes, yes. Are you talking? I'm not
Can you hear me
hearing
now?
you.
Can you hear me, Professor?
Oh, you guys hear? I cannot hear. Oh, maybe I can hear now.
Hello?
Are you? Oh, yes, I hear you now because I mute myself. I mute myself on the computer. Okay, I'm good now. I can hear you. Go ahead. Thank you.
All right, so I'm not gonna rewrite the question, but I started off by pretty much assigning the variables. So I had a over x, which was the first part of the denominator, and then I plus b over x minus 1, and then plus c over x minus 2, and then it was lastly plus d over x minus 3. Since there were 4 parts of the denominator, I was able to split it into 4 4 letters. All right. And then basically I multiplied the denominator on both sides, and that was able to cancel the denominator on the left side, or the integral, and that left me with 1 equal to a times I'm not gonna write. It's actually pretty long to write everything out.
Right,
'Cause
the numerator is just 1. You're right.
Yeah.
If you
And
want, I'll write for you. You can write this. This is equals to 1 over the common denominator, x. We can use this, x times x minus 1 times x minus 2 times x minus 3. Right, you have made this.
yes, correct.
Yeah.
So then I multiplied that denominator by both to both sides to cancel it out on the other side. And so a over x, right? The x is already there, so I just multiply x minus 1. Actually, I think I'm just gonna write it down actually.
Okay. You could use the square T to type. Typing is much easier than writing.
Yeah. Those are times x minus 2.
Paul, you did it exactly right, Paul. I see you typing in the chat.
3. Then it was plus b times x minus 2 times x minus 3, and then plus c times x minus 1 times x minus 3, plus lastly d times x minus 1 times x minus 2, or x minus 2, sorry. Okay, and then so because here they were all like linear, I went to and I started strategic substitution, that method, instead of the other method, because it was going to be easier. So then I started off with the first variable being x equals 1. No particular order, but x equals 1. Pretty much I plugged in x equals 1 for all of them, and as you can see, if you plug in x equals 1 for a, that becomes x minus 1, or 1 minus 1, which is 0, so automatically a becomes 0. You plug it in for b, and all that becomes 2 times, or b times 2. C becomes c times 0, cancels out. D becomes d times 0 as well, cancels out, and you're left with 2b is equal to 1 divided by 2, and b equals 1/2. That's how I got b. For the second one, I did x equal. I'm just gonna, Professor, do you mind if I just basically do what I just said, like just say it out, or do I have to write the whole thing out?
Yeah, I'm trying to figure out what are you doing. Because what I would do is I would just expand those linear factors. So I would
Right,
get, yeah.
Yeah, but
One,
that was the other method. I went with strategic substitutions, just straight up like plugging in numbers.
but there are millions of numbers. Which one? How do you know which one works?
Oh well, that's why it's called strategic substitution. You just pick you see like for example, to cancel out a, you would just have to plug in 1, and that also works for every other variable but b, and that would leave b with an actual number next to it, and then that's how you get b, if that makes sense.
Oh, okay. Hold on 1 second. Let me think. Let me think. So you are saying, because we have factor of 1, factor of 2, factor of 3, factor of 0, maybe you can just plug in these 4 possible numbers?
Yes.
Okay, so you are saying, right, let's plug in x equals 1. Because those are the 4 factors. So when we plug in x equals 1, I can type for you. And we get a 1 equals to, so the factor with a becomes 0. We're left with
Right.
bx, x minus 2, x minus 3, and c is gone, and d is gone. So we have this. So 1x equals 1. Then we can do when x equals 2, right?
Well, I plug in 1 for b because you're also plugging it in for every other variable. And then when you plug it in for b doesn't cancel out. Yes.
Interesting. Okay.
And
So
that
we
makes
plug
b
in
2b.
x equals 1. Now we get this. Now we plug in b equals 1.
No, not for b. I meant because you know how you plugged in 1 for every other or every other variable like x minus a times x minus 1.
Right. This
Yeah.
is just right. I'm just okay. So this is just 1 minus 2. That's negative 1. Right?
Yeah. Yes.
1 minus 3. That's negative 2. I forgot to plug into this.
Yeah.
So now we get. Oh, how does this work? I'm interested. Thank you so much. So
Yeah,
b equals to negative. So b equals to half.
Yes.
Right? Really, this works. So now we plug in x equals 2. So if x equals 2, we get a 1 equals to a times 1. Forget about the 1. Oh no, we get a 0. A term we get 0. B term we get 0. So we only left with c term. C term we get a c times 2. Right? C times 2. I'm going to write this. And 2 minus 1, we get a 1. 2 minus 3, we get a negative 1. Now you can see it. So we plug in x equals 2. So we get a 1 equals to only c term survives. So multiply by 2. 2 minus 1 is 1. 2 minus 3 is negative 1. So we solve this. We get c equals to negative half. Right?
Yeah.
Wow, thank you. I never learned this way. Thank you for teaching me.
Yeah, no
Ali.
problem. It was actually on the textbook too.
I didn't even read it.
Oh, yeah.
Yeah, maybe I was supposed to learn this long ago. I just forget or something. Yeah, then x equals 3 will solve for d. Yes, Paul. Thank you for the question.
Yeah, it also works. It also works for quadratics as well, not just linear, which I found surprising.
Oh, it also works for quadratic. What do you mean?
Like instead of x minus 1, it would be like x squared minus 1 or whatnot, you know?
Oh, you mean when we go to a higher
Correct,
okay.
correct, yeah.
The factor with a higher multiplicity than 1.
Yeah.
Okay, great. Beautiful. Yeah. All right. So everyone, we have this new method, much simpler, much easier. Yeah, I need to keep learning. Thank you. All right. So the second question is, anyone has question with this question? All right. If not, let's go to 3.47. 3.7. 3.7. Improper 355. Okay, let's all try 355. Maybe some of you teach me some new strategies. I'll try 355. We see product. We see a product. We see the integrand is a product of two functions. So first, well, we have to deal with this infinity sign. So we're dealing with, so the upper limit is an infinity sign. So we have to use the improper integration skill. But then the integrand is a product of two functions. We have to use integration by parts. So let's all try this. Damon, when I do IBP, what's IBP? Oh, integration by parts. Okay. I keep going back and forth between, okay, so that's why, choosing V, choosing U, sometimes, we have, right, we have to practice, then we're having good eyes to recognize U and V. So in this case, you see e to the negative x, right? The derivative of, think about e to the x, the derivative of e to the x is e to the x itself. It's close to the u here. Between is close to the u here. I think it's e, not close. So we'll try it. I'm not going to tell you which is which. All right. You try one way, it didn't work. You go to another way. Actually, hold on. Yeah, this one is tricky because we're going to be running in circles. Sine x, cosine x, e to the x, e to the x. All right. Yeah, there's a little trick in this question. Can you show us how to do this question? Okay, so anyone has answer for this? All right, let's go to the whiteboard. So this is an interesting question. And sometimes we have to do, sometimes the question is not strict. So we have to give a little bit, we have to use a little bit of trick. So so let's deal with the infinity sign first. So this will have 3 parts. Do you do something with the repeating integral? Yes. So the strategy is, because sine and cosine, you know, it keeps changing, right? You let and the e to the x, you differentiate, you keep getting e to the x, you keep getting e to the x, cosine x or sine of x. But so once you get to e to the negative x, cosine x again, you see that on the equal sign of both sides, you have 2. So what can we do? We just shift 1 to the other side. So we will double it. We have 2 of them. We have something on the right-hand side. We have 2 of the original question on the left-hand side. So we just divide the stuff on, I'll show you on the right-hand side, the integration UV, the 2 UVs divided by 2. Remember now, Damon? Okay. Yeah. And so it's similar to one of the important mathematical question. What was it? It's in physics. I forgot its name. You have to basically you have to running in a circles. But once you hate, it's like you're running in a circle. You're running in a circle, right? So when you're running, you get something else. So then when you go back to the point, you have some double, then you have the rest of it. Yeah, you just have to play a little bit of trick here. Okay, let's go over this one. This one is worthy of doing it. So we have e to the negative x cosine x. Yeah, it's difficult to write with your fingers. I'm going to try to type. So first we're going to see, okay, like this. So first let's deal with the limit, right? Then I can only type this. With the limit, we use a dummy variable, t. Then in the limit, we let the t run to infinity. All right, so the integrand, we still have the same thing. We have e to the negative x and cos x dx, right? So what do we want to do now? Now we have a choice, right? Maybe we let e to the negative x, e to the negative x. So so we want to do uv. Let me put it over here. We want to do uv minus the integration of, we'll have maybe u dv equals to uv minus v du, right? U dv. Okay, I got it. Is this good? Okay for everybody? Yeah. So we need to figure out which one to be u, which one to be dv, and so let's see. So u to be e to the negative x dx, v or dv to be cosine x dx. Okay, so first we have this. Now let's figure out. So du is negative e to the negative x dx, and okay, then v equals to sine x, right? So I let u to be e to the negative x, and then du is negative e to the negative x dx, then dv to be cosine x dx, so then v is sine x. If I make mistakes, let me know. So now I can rewrite this. So I use this formula. I can rewrite. Let me just type, then I use the sign. du is negative, right? Negative e to the negative x, right? Negative, right? You can see negative 1 over e to the x, or you just see negative e to the negative x. Yeah. So now this whole thing equals to, not this whole thing, but the limit 1. So I'm not going to write the t goes to infinity, okay. So it's the limit when t goes to infinity. I'm going to leave sign, leave space for the integration sign. Now I have, let's put a big parenthesis here. So I have uv, which is e to the negative x. V is sine x, right? Minus the integration sign, I'm going to put it later, minus integration v du, sine x, and du, which is negative, so I'm going to have plus, right? Negative, negative become plus. Plus sine x, I'm going to leave space for my integration sign. So sine x v du is negative e to the negative x dx. So that's my second, right? So my second one. So I'm not going to write t run to infinity, okay? And you understand that that's t run to infinity. Oh, let me put these signs here, integration signs here. So 0 to t, all right. 0 to t. Okay, now I'm going to apply integration by parts again. So I can okay, let me write here. I can put equal sign. Let's just take a limit of e to the negative x sine x on the side. Okay. Now I'm going to do plus limit of this second one. Oh, hold on 1 second. So this is in wrong spot. This is supposed to be here. This integration sign only supposed to be here. So the first part is u times v. So e to the negative x is u, v is sine x, it is uv by this formula, right? So uv, I have limit of uv plus limit of this integration sign. So now I need to figure out my u and v again. So let u be e to the negative x, e to the negative x, right? And let it dv to be sine x dx, right? Then I figure out my du and my v. So my du is negative e to the negative x dx, and my v is negative cosine x. So I'm going to use this, plug into here. Oh, hold on. This should be, so I gotta move this one. Because I have UV again. I'm doing second round. I'm doing integration by parts for sine x e to a negative x now. So I get a UV again. And then my new u still e to the negative x, e to the negative x. And my v is negative cosine x. So I'm going to put the negative sign. Let me see if I can change this one. Change the negative sign there. And sine x, right? That's my new uv. Then minus my v du. Minus my v du. What's my v? My v is negative cosine x. My du is negative e to a negative x dx, and negative become positive. So I have e to the negative x and cosine x dx. You see the term I want appears now. Right, so this is 0, this is t. Right? So now my left-hand side, oops. You see I have this guy. I started with this guy, right? Oh, actually I started with this guy because we could just take a limit in the end. In this case, probably it's better to take a limit in the end. So this guy now equals to this guy. And of course I can split the limit, so I can take a limit of this one, a limit of this one, right? You see this one is the same as my starting one. So what I'm going to do, and especially it's negative. If it's a plus, if it's positive, I'm doomed. I cannot do anything, right? The beautiful thing is this is negative. That means I can move this one to the other side. Now, when I move this one to the other side, I get 2 of this, right? I get 2 of this. Because the negative, I move to the other side, become positive. I get 2 of this equals to this. Equals to this. So it's just divided by 2. Okay, so that's a trick for this type of questions. Right, with the periodic functions, this method is used all the time with the periodic functions. Sometimes it's not function, sometimes it's not, like a periodic expression, something running with circles. Sometimes we deal with circles. What was the question? E to the x squared plus y squared. What's the name of it? It's proving some way like this. All right, so who asked this question? All right. Oh, Damon. Okay. So it makes sense, right? All right. Good. So that's the only 2 questions being asked. So then you calculate for 0. Yeah. Okay. Then the rest. Let's finish it. Then the rest of it. Let me see. Well, the rest of it, we just use the limit. So we have limit when t goes to infinity. Remember, t goes to infinity. Oh, hold on a second. This 2 has nothing with t, right? You see this one and this one. We just get a function in terms of x. Hold on. So t goes to infinity, right? T. Okay, hold on a second. Let me check. Did I make any mistakes somewhere? Because I get in. I got e to the negative t. Okay, let's finish this. We get e to the negative x sine x, or we could write a sine x divided by e to the x sine x divided by e to the x. Right, I can put the e to the x on the denominator now. Then that's minus. Is this minus? Let's see. Plus this. Oh, minus, right, because it's negative. Okay, that's right. Minus. No, it can't be right. It cannot be minus. Because if it's minus, those 2 terms cancelled. I think I made a mistake somewhere. Oh, okay. Yeah, it looks like I made a mistake somewhere. Oh, yes. So this is a mistake. This is supposed to be cosine x. Because this uv, you see, this is u, this is a v. The negative cos x is v. So this is supposed to be, because it's supposed to be negative minus plus u times v, because this cosine x is negative, so that's why I change this one to be minus e to the negative x cosine x. So this is supposed to be cosine x. That's why it doesn't look to me, doesn't look right. So the answer should be e to the negative x sine x minus e to the negative x cosine x. Then we want, so limit when t approaches 0, and then what do we have? We have sine x. All right, as long as you got it now. Okay. Okay, great. All right. Anyone has any other questions? Oh, we have one more person. Oh, okay, James came in. James. What? Okay, any other questions? I have some blackboard problem. T equals to infinity, 0 equals to negative e to the x, so it's 0 converges. What was the original question? Let me go back to see the original question. So determine whether the improper integral converge or diverge. I see. Okay. Let's see. So we have a limit t runs to 0, but now, So we start from the beginning, 0 goes to infinity, but then we got rid of the limit sign. So we take the limit, we say, okay, let t runs to infinity. We get this. Then the second one, we get this to take a limit, t runs to infinity. We get a uv. Then we did this one, we get a uv. And this one, we move to the other side. So we're seeing limit of this one, the improper integration equals to limit of this when t goes to infinity, which is e to the negative x sine x. And the limit, and this one, we don't need this limit anymore. All right, so we get a function in terms of x, but limit of t goes to infinity. We get a function in terms of x. It has nothing to do with t. T goes to 0, goes to -1. What do you mean by that? T goes to infinity, 0 goes to... It converges to half. T goes to infinity. T goes to 0. No, t goes to infinity. T goes to infinity, the denominator, so e to the negative x goes to x, sine x. It's a half or negative half, the answer key. So I have sine x e to the x, positive half. We have sine x divided by e to the x minus cosine x divided by e to the x. Okay, then, so I forgot something here. I forgot it from 0 to t, right? This is all from 0 to t. Well, at t, let's calculate this. So at the t, we just get a sine t. Let me tap. Too difficult to write with my finger. So that's sine t over e to the t. Minus cosine t divided by e to the t. Then minus, let's give a parenthesis, minus sine 0. Sine 0 is 0, right? Forget about it. Sine 0 is 0. And then minus negative cosine 0. Cosine 0 is 1. 1 over e to the 0, which is 1. So which is minus 1 here. Minus 1. And everything divides by half. Right? So this all under half, with a factor of half. Right, so I have this, then take a limit. So take a limit of this. Take a limit of this, and let t run into infinity. Okay, now let's see. Sine t, limit when t goes to infinity. Remember the identity? Sine t over e to the t. That's 1, right? So this one is 1. Limit when t goes to approaches infinity, sine t over t. Sine t over t. That's not e to the t. sine t over t. Let's multiply t over t. So let's multiply the first term. Let's multiply the first term by t over t. So we want to manufacture a t in the denominator. So let's multiply by t over t. Then limit, so this part with the denominator of t goes to 1, right? Or you could think about sine t. So then we have 1 over e to the t. We have t over e to the t. And t is linear. T is linear. So e to the t is exponential. That means t over e to the t runs to infinity, runs to 0, approaches to 0. So we have negative, so we have negative cosine t over, probably we'll do something similar with this. I don't know what's this one going to be. Cosine t e to the t. What we can do, okay, so this is a cosine t over e to the t. Yeah. So that then we get a negative sine t. Oh, negative cosine t, that's sine t. We can do L'Hopital's rule, right? So we get a sine t over e to the t. So same thing we get as the first one. So basically the first two terms give us a 0, right? The first two terms. Then we have minus negative 1. Well, that's positive 1. Positive 1 times a half, we get a half. All right, so this question involves a lot. Now I understand why Damon has question over this one. Okay, I probably confuse you. Should we do from the starting point, start over of this question? Anybody like me to go over this one? Because this one is a lot. Can I not put this on the midterm? This kind of question is like a homework question. It won't be an exam question because it takes too long to do it. Exam question should be, you know, sweet and short. And no, yeah, exam question will be sweet and short, just to test it to see if you master the techniques we learned in this course. But it won't be. This probably takes too long. When I'm younger, probably I can do in a shorter time. Now I'm getting old. It took me a longer time to do this. No tricky questions on exams among CUNY. Nope. No tricky questions. About 20 questions on the midterm, also on final. I haven't really made the exam yet, but normally for courses like this with 2 hours, normally it's like 20 questions. Okay, any other questions? Getting dark now. I will post, I will post the Zoom link. I will post the Zoom link before exam. I will post on Blackboard. I will post on the chat also. Any other questions? Yeah, you're right, Paul. Camera on, microphone off, except when you want to talk to me. How many questions for each section? Well, we'll only cover 1 to 3 chapters, right? How many sections in total? All right, great. At least one question from each section, I guess. Then for important ones, let's go to okay, you can see my screen, right? So they say you will have question from section 1.2, 1.3, 1.3, at least 2 questions, because fundamental theorem of calculus have 2 parts, right? Integration, substitution, involving it. So let's see, 2, so 1, 2, 3, 4, 5, 6, 7, 8, and we have 2 methods, right? Disk method and shell method. So that counts as 3, 6, 7, 8, and also revolving with x-axis, revolving with the y-axis. That's probably up to 7 questions now. And the arc length of a curve, surface area. So probably by 8 or 9 questions now. Integration by parts, maybe 1 or 2 questions. Trigonometry 3.2, 3.3, partial fractions, improper integrals. And let me see your comments. Are there any important sections that you plan to have extra questions for, such as integration by parts? Yes, integration by parts is important. Also, let me see. Do we need to email you the answer? Yes. Right after you finish, you're going to tell me you're finishing up, you're emailing me, and I'll check if I received it. Once I received it, you're free to leave if you finish early. Yeah, basically, you know, the midterm will cover every topics we have discussed so far. Not only chapter 1, chapter 2, chapter 3. Okay, only 3 chapters. Yeah, from homework. You can imagine how many homeworks we had. We had 10 sets, right? Yes, so we have 10, but the number 10 is from the new chapter. So 9 homework. 9 homework plus online one. So it's indeed 10. It's indeed 10. So you may assuming I would choose, you know, 1 to 2 questions from each one. How many hours do we get? Okay, we'll start 6:05 promptly. So I can go up to 8 o'clock if we really need, all right? So it's like 1 hour, 55 minutes. Yeah, if you can, right. So by, let's see, if we really need that much time, we will finish by 8. So from 8 to, you know, 8:10, or give you 5 minutes to email me, to take pictures, to email me. All right. Will there be any curve? Oh, I don't think you need any curve, right? I think you guys are pretty smart. Ali, you have taught me a new thing today, which I you know, I appreciate that. You need curve. Let's see how well, you know, we're doing, you know, as a group. We you know, you haven't even tried yet. How do you know you need a curve? If you know you need a curve now, you have to study from morning to night for this exam. Wow, you think you're going to fail this exam? Well, that probably means you haven't studied hard enough yet. When I was your age, when I started this course, you know, the textbook was from James Stewart. It's like a classic calculus book. I had almost done every question in the exercise. Anyway, if you don't feel good about this exam, you know, study very hard from now until the exam. All right, put your time into it. Don't play games anymore. Quit games for a couple of days. My son is also in college. I know he plays a lot of games. He's telling me he's not getting A. I said, well, you know what to do. Okay, I know all of you are smart. All right, you're smart, you're young. The only thing is you have to put your time into this. That's all you have to do. Spend time with this, with the questions, all right? And you will pass. Okay. All right, anybody has any other questions? Okay. All right, thank you. And I always learn from you too. I always learn to be, you know, how to teach students better. Yeah, you students always teach me how to be a better teacher, and I'm grateful for that. All right, so good luck, everybody. Spend more time with the questions. All right, you'll do fine. All right, have confidence in you. I have confidence in you guys. Okay. All right. Good night. Good night. Good night. Okay, James. Yes, you came a little late, but let's see. Yes. So I'm going to put the details about the midterm, you know, how you take the midterm, what do you have to do, what do you have to be careful with. I'm going to put the details on Blackboard. That's okay. That's all right. It's okay. Yeah, we all have situations. Don't worry about it. All right.